Namaste. Today we are going to conduct alkalinity test. So for the alkalinity test, we require learning objective. Understand the concept of alkalinity. The methodology is to determine the alkalinity. So the aim of the experiment is determine the phenolphthalein alkalinity and methyl orange alkalinity or the total alkalinity of the sample. The requirements: 25 ml conical flask, 250 ml conical flask, 250 ml beaker, 50 ml burette, then pipette, then the chemicals required: standard sulfuric acid, that is 0.02 normal H2SO4, then phenolphthalein indicator, then methyl orange indicator, then 0.1 normal sodium thiosulfide, then distilled water we require. Next, the theory part. Alkalinity is a measure of ability of the water to neutralize the acids. The major portion of the alkalinity is in the natural water, that is caused because of the bicarbonates, carbonates, hydroxides, then calcium and magnesium. Right. So we can see when these carbonates and bicarbonates are there, the water becomes alkaline and the water becomes hard. Right. Then the pH values will goes on increasing, 4.2 to 8.2, then 8.2 to 11, then 11 to 14. Next, so what are the problems when alkalinity is there in the water? The boilers which is used in the industrial starts scaling in the inner surface, and also it has a small significance for the public life. Then the highest values for the alkalinity is, it should be for the drinking water, it should be less than 250 mg per liter or 250 ppm. Then it will cause bitter taste in our tongue. Then excess alkalinity is harmful for the irrigation, which leads to damage of the soil fertility and reduce the soil fertility. Then for the RCC work also, it should be less than 250 milligram per liter. So if the water becomes alkaline, then we have to go for the treatment. So these are the concepts of the alkalinity. Now we are going to see the test, how we are going to conduct. Jai Shri Ram. Another experiment we are going to do today, that is alkalinity. Alkalinity experiment, we require burette, conical flask, pipette, then funnel, then chemicals: phenolphthalein indicator, methyl orange indicator, then sodium thiosulfide. For the burette, we require 0.02 normal H2SO4. So I have already poured H2SO4 in the burette. I have taken 25 ml of the sample. I have pipetted and poured it into the standard conical flask. Next, I will add 2 drops of sodium thiosulfide, that is to remove whatever the chloride contents present in the water. Right. So next I will add phenolphthalein indicator. So now immediately the color changed into pink. Now the reading is 1.8. So initial reading is 1.8. I will start titration. Very slowly I have to do the titration until the color of the solution, pink to it should become colorless. Now the color of this is colorless. That means pink to colorless, it is already achieved. So note down the reading. 2.5 was the initial reading. Now it is 3.8. Okay, so V1 is equal to, or phenolphthalein alkalinity, we require initial reading and we require final reading. The quantity which is consumed is final reading minus initial reading, right? So for this, next I have to continue for the methyl orange alkalinity. Once again, I will add for the same sample methyl orange indicator. You see the color now? It is light yellow, right? So initial reading now it is 4.5, right? That is initial reading. Slowly start titration. Now it has become reddish color, very, very light red color. So note down the end point, note down the initial reading and note down the final reading. Now the final reading is 16.5. So final reading minus initial reading is the total amount of H2SO4 consumed for the methyl orange alkalinity. See, in this experiment, at the beginning when I have added phenolphthalein indicator, if the color does not come turned into pink, the sample remains colorless, then we have to write down that phenolphthalein alkalinity is 0. No need to titrate it. Immediately I have to add methyl orange. So when I add methyl orange, you will get the yellowish color, then it will come to pink color, right? So this is the experiment for the alkalinity. Thank you. How the calculation is done. So we have seen how the phenolphthalein alkalinity is done and also methyl orange alkalinity is done. So here V1 is the volume of the sample which I have taken, and the volume of the sample which is consumed, or the titration values. N is the normality, 50 is the molecular weight, then ml of the sample. Here it is, say I have taken 25 ml of sample which is taken in the conical flask. So initial, say initial reading is 0, final reading is 2.3 example. So it is 2.3 minus V1 is equal to 2.3 minus 0, that is 2.3. So what I have to do here? 2.3 into normality is 0.02 into 1000 divided by 25 ml of the sample which I have taken. So whatever the value is there, that is milligram per liter. Similarly, methyl orange alkalinity. Here for the second titration, what is the value? So initial reading is, say for example, it is 2.3. Final reading is, it is 5.3. What is the V2 value? V2 value is equal to 5.3 minus 2.3, that is 3, right? So here once again I have to take 3. Here it is 0.02, 50 into 1000. How much volume I have taken? 25 ml. Say this is X value. If this is Y value, then what is the total alkalinity? Total alkalinity is X plus Y mg per liter. X plus Y mg per liter. That is the total alkalinity. Next, if I have total alkalinity, next we have a one table. Here, now say here, I have to calculate what is the hydroxyl alkalinity, then what is the carbonate alkalinity, what is the bicarbonate alkalinity. For that, say whatever the value I have taken x, that is taken as P. Then what is x plus y total, that is taken as T. So two values I should know from the calculation. Say for example, this is 50, this is 25. So P is equal to 25 and T is equal to 50. Then if P is equal to 0, that means phenolphthalein alkalinity is 0, then hydroxyl alkalinity is 0, then carbonate alkalinity is 0, only bicarbonate alkalinity is there, that is T. That is not my case. Next, P is half of T, whether less than half of T. What is T value? 50. What is P value? Say 25. Whether it is less than half of T? In this case, no. It is equal to half of T, right? So this condition will come. But if it is, say for example, P is equal to 20, then it is less than half of T. In that case, hydroxyl alkalinity is 0, carbonate alkalinity is 2P. That means, say it is 20 means 2 into 20, 40. Then 50 minus 40, that is 10. Whatever the example I have taken, that comes to this. P is equal to half of T. Right. So hydroxyl alkalinity is 0, carbonate alkalinity is 2P, then bicarbonate alkalinity is 0. Say in that case, if P is equal to 30, then this condition will come. Then it is 2P minus T. That means 30 into 2, 60 minus say T. That is 50. 10. Here 2 into T minus P. That value, then 0. If P is equal to T, that means methyl orange alkalinity is 0, then hydroxyl alkalinity is T, then carbonate alkalinity is 0, bicarbonate alkalinity is 0. Right. So what is the table we have? Sample, first phenolphthalein indicator, final reading, initial reading, volume V1. 3 trials minimum we have to do. Then methyl orange also we have to initial reading, final reading, initial reading V. Average of this V2. Right. So after the calculation is over, the result is written in this way. What is phenolphthalein alkalinity? In the table, we are going to write phenolphthalein alkalinity in terms of calcium carbonate, what is the value? Then methyl orange, total alkalinity, hydroxyl alkalinity, carbonate alkalinity and bicarbonate alkalinity. If using this result, we can conclude that whether this water is suitable for drinking or RCC work or irrigation or not. Right. So this is how the alkalinity experiment we are going to conduct for the water sample. Thank you.